So.
Alright, so before we go over how to do polynomial long division, we're first going to go over a couple of the polynomial terms that will be useful for the lesson that is going to go after. So these are some of the terms we're covering today, and first we're going to start with a problem to help explain each one. So we're going to put our problem up here. It's going to be 5x to the fourth minus 2x cubed plus 3x squared plus 21x plus 5. And this is just one example of a problem that could be done, but there's a lot of different ones. Alright, so a polynomial is basically the product of a constant and variable. So in the problem, 5x to the fourth is one example of a polynomial. It has the 5 and the x. Alright, now, a leading term in an equation like this is the highest number with a degree. So the leading term here is 5x to the fourth. And again, the example in this problem is 5x to the fourth. Now, leading coefficient is similar, but instead of using the whole term 5x to the fourth, it's the leading, one second. It's actually the leading coefficient. Wentworth, we're doing a video. Go away. You're so impolite. So, getting back to the problem. The leading coefficient is the, we'll say, leading number with highest degree. So basically all I'm saying with that definition is that going back, this is the leading term, but when they ask for leading coefficient, they're only asking for the 5 in 5x to the fourth. So if we wrote 5x to the fourth, they're not looking for that, and they are looking for the 5. So that's all they're looking for. The degree is just what the number is brought to. So in 5x to the fourth, the 4 is the degree. So if they ask you for the degree, you can write 4. Alright, a constant is a number that always stays the same. So it's the opposite of a variable. So for example, a constant would be 10. 10 is always worth 10. It's never worth 20. But x is sometimes 4, 10, 200. It doesn't matter. So this is not a constant. Now we're going to finish with the terms linear, quadratic, cubic, and quartic. So an example of a linear problem, and this also stands for the definition, is 4x plus 3. And the example that we're going to use is that on a graph, it'll look something like that. Alright, for a quadratic equation, it may look more like this. And on a graph, that would maybe look like that. So we go from a straight linear line to a parabola. Next is cubic. An example of a cubic problem would be 2x to the third minus 5x squared plus 3x minus 10. So as you can see, it's getting a lot more confusing in what we're doing. And this isn't necessarily for this problem, but in general, this problem aside, a cubic might look something like that. But this doesn't represent that problem exclusively. And then a quartic, one example would be x fourth plus 3x squared. And if you plotted that on a graph, it would look like, well, it would look like this.